There's two questions that Glory wanted me to do with her, so I'm just going to start them while we wait for her. So Glory, if you're not by your phone, I hope you're watching. And the rest of you out there, remember, trig identities. Proving left-hand side equal to right-hand side. Very important. Glory, are you there?
Yes.
Okay, welcome to the show, Glory.
Yes, thank you.
Okay, so, right, prove the following. Prove the following. There's two questions. So the first question is tan squared theta minus sine squared theta is equal to tan squared theta times sine squared theta.
Yes.
Okay, shall we do that one first?
Okay.
Okay, so a good thing to always do is to change everything to sines and causes, right?
Yes.
So what can I do? What can I do to start here? Let's first identify which is the more complicated side, the left-hand side or the right-hand side?
The left-hand side.
Okay, I agree with the left-hand side, although it's not really clear. In actual fact, in this case, it wouldn't really make a difference which side you started with.
Yes.
Okay, but agreed. Let's start with the left-hand side. What do I do now?
Change the tan squared theta to sin squared theta over cos squared theta.
Good, I like it. So I'm going to say sine squared theta over cos squared theta.
Yes.
Okay, minus sine squared theta. What next? Equals. What do I do when I have fractions?
Make the denominator to be the same.
Okay, good. Find an LCD. What is the LCD, Glory?
Cos squared theta.
Okay, so what do I do then?
Multiply the sin squared theta with the cos squared theta.
Okay, I like it. So I'm going to get cos squared theta, sine squared theta like that, right?
Yes.
Are you with me? You could write
Yes.
sine squared theta, cos squared theta, same thing.
Yes.
And that's all over what, Glory?
Cos squared theta.
Cos squared theta. Brilliant. What next? What now?
So simplify.
Okay, I can't simplify any further. Look, I've got a sine squared and a cos squared, sine squared. So a good thing to do, you need to look for it. Always look for the factorization. Always look for the factorization. Okay, you need to be aware, Glory, when you're doing these questions. Okay, part of the preparation that you need to do is to know that when you're doing proving left-hand side equals right-hand side, and equations for that matter, very often in the question you need to factorize. So you need to look for it. It's not just going to jump out at you. You need to be thinking right from the beginning, okay, when can I factorize? When can I factorize? When can I factorize? Are you with me?
Yes.
So what can I factorize here?
I couldn't go any further. Wait.
Okay, let's have a look at it together. What do you notice on the top? What's common?
It's sin squared theta.
Can I pull it out as a common factor?
Yes.
Okay, so I'm going to get sine squared theta and then a bracket. And then what?
Yes. 1 minus cos squared theta.
1 minus cos squared theta. Great. All over cos squared theta.
Yes.
Okay, now what is 1 minus cos squared theta?
Sin squared theta.
So what I end up with here is sin squared theta times sin squared theta all over cos squared theta.
Yes.
But haven't I finished? Look at the right-hand side here. What am I trying to prove? I'm trying to prove
The tan squared theta
times sin squared theta. Now have a look at what I've got.
Yes.
I've got sine squared theta over cos squared theta. What does that give me?
Oh, tan squared theta is sin squared theta over cos squared theta. Okay.
Tan squared theta times? Are you
Sin
with
squared
me?
theta. Yes.
Because these two together, that one there, those two give me my tan.
Okay.
Are you with me?
Yes.
And what I'm left with is the sine squared theta, which equals the right-hand side.
Okay.
Okay, so let's talk about what we use there. And you must write this down. Okay, important. NB. Write this down. So the first thing we do is we change to sines and causes.
Yes.
Okay, that's always a good way to start. Sines and cos. Okay?
Yes.
Another thing to do is to factorize.
Yes.
Another thing to do is to use your squared identities. When we used our squared identities here, sine squared theta plus cos squared theta equals 1. We used that.
Yes.
Right, so there's some hints for you. You need to look out for them. Right, let's do the second question here. Just going to go into a new page. Again, it's prove left-hand side equals right-hand side. That's the instruction. And the question that we have here is sine x all over 1 plus cos x plus 1 plus cos x all over sine x is equal to 2 over sine x. That's the instruction.
Yes.
Right?
Yes.
Which side do I start with?
The left-hand side.
Okay, and what do I do with it?
Make the denominators come.
Okay. What are the denominators?
1
there's-
plus cos.
There's a big denominator.
Yes.
What is the denominator on the bottom?
It's 1 plus cos x
Yeah,
times sin x.
I like it. Now what do you have on the top?
Sin squared x
Yeah.
and 1 plus cos x to the power of 2.
Okay, well done. I like it. Like that. In other words, I need to times that whole thing by that and that whole thing by that.
Yes.
Okay, let's simplify the top. Equals. So I have sine squared x plus, FOIL this out for me. I'm listening.
Sorry?
I said FOIL this out for me. Multiply out the brackets for me.
Oh, it's 1 plus 2 cos
Yeah.
plus 2 cos x
Plus.
plus cos x squared.
Good, I like
Cos-
it.
Okay.
Okay, well done. You're doing very well. Let's keep going. 1 plus cos x on the bottom. There's no point in breaking up this bracket on the bottom because it's already nicely factorized and I'm hoping that things will cancel out. Right?
Okay. Okay.
Okay. What can I do on the top now? What do you notice here? Look, I've got a sine squared and I've got a
Oh, sin squared and cos squared gives 1.
1. Great. So I have a
Yes.
1 and a 1 plus another 1 is
2.
2. So I have 2 plus 2 cos x, right?
Yes.
All over sine
1
x,
plus cos x sin x. Yes.
1 plus cos x.
Okay.
Now what? What did I say to you before? You must look out for the... We spoke
Look out for
for the... In the previous question, I said it's not just going to jump out at you. You need to be thinking, what must I do?
factorize.
Factorize. What can you do now? What can you factorize?
Oh, take out the 2.
Right, do you see? It comes up again. You got to think about it, otherwise it's not going to work for you.
Okay.
And you're going to lose marks on a very easy question. Are you with me?
Yes.
Look, 1 plus cos x on the bottom.
Okay.
And what am I left with?
2 over sin x.
Gone, gone.
Oh.
Are you clear?
Yes.
Equals 2 over sine x. Nice and easy.
Oh.
Equals the right hand side. Are you happy with that?
Yes, I'm very happy with it. Thank
Okay. Okay, thanks for calling, Gloria. Please feel free to call us again.
you. Okay.
Okay, good luck, eh?
Oh, thank you.
All right, guys, that was Glory, and a very typical trig equation, trig identity question. Remember the things that you can use to help you in the question. Look for factorization, look for LCD on top, LCD on bottom. If there's fractions over fractions, tip and times, factorize, squared identities. These are all things that you need to be thinking about when you do these questions. It's part of your preparation.
Keep that frequency clear. Keep that frequency clear.
it.